All right, this video is part 3 of a series of videos on radicals and exponents. So last time in the second video I went over all of these exponent rules, and we are going to use those and what we know about radicals to do some problems. Now I've left number 2 on here, but let's do number 1 together. So on this one, the bases are the same. They're both 49, and they want us to multiply, which means that we need to add the exponents. So when I add my exponents, I'm going to have 3/4 plus negative 1/4. Okay, well, let's write this a different way. I'm going to have 49 to the 3/4 plus negative 1/4. All right, well, that's not so bad to add together because they have common denominators. So 3/4 and negative 1/4 is 2/4. 2/4 is really 1/2. And now we know anytime we have something to the 1/2 power, that is the square root of 49. Okay, and everything that we do is going to be in radical form. And the square root of 49 is 7, so that is our answer. Now let's see what happens on number 2. Here, I've got the same base. They're both 81. And so we're going to add the exponents. So I had 5/6 plus 1/3. But I can't add fractions unless they have common denominators. So I'm going to change that 1/3 to 2/6. So 5/6 and negative 2/6 gives me the 3/6 right over here. And 3/6 reduces to 1/2. So this is 81 to the 1/2. And like, if there's anything you take away from this lesson, anything to the 1/2 is the square root. So square root of 81 is just 9. All right, let's try this again on number 3. On number 3, they've got the same bases, so we need to add the exponents. But this one has a typo in it. We're going to make this negative 5/3. So we'll change that. So this is 27 to the 7/3 plus negative 5/3. Well, this gives me 27. 7/3 and negative 5/3 is 2/3. Okay, anytime we have a fractional exponent, then we're going to need to rewrite it. So when I rewrite it, that's going to be the cube root of 27, because remember the denominator goes in the radical, and then my exponent is the numerator, so this goes here. But remember, when this was a number, we found it easier if we wrote it like this, or we didn't. I told you it would be easier if we wrote it like this. And the reason is, now this is going to be easier to simplify. We know the cube root of 27. The cube root of 27 is 3, and then we're going to square it. So 3 squared is 9. And I replace this with a 3. These things are equal. That's why I was able to do that. Okay, let's look at number 4. Now, when you have problems like 4, 5, and 6, your goal or your strategy should be to reduce everything in the parentheses first, then do power to a power. So over here I have x's on the top and I have x's on the bottom. This is a division problem, and when we divide, we subtract our exponents. So the first thing I want to do is simplify inside the parentheses by subtracting my exponents. Well, I'm going to do my fraction work off to the side. So I know I'm going to have to do 2 minus 1/3. Well, to be able to subtract these, I need common denominators. So this is going to be 6/3 minus 1/3, which is 5/3. So now inside I have x to the 5/3 all raised to the 1/5. Now this becomes a power to a power, and when it's power to a power, oops, not writing clearly, let's try this again, you multiply the exponent. So this is going to be 5/3 times 1/5. But before you multiply, you should always reduce. So when I multiply straight across the top, I get 1, and then on the bottom I get 3. So this is x to the 1/3. But we cannot leave anything with a fractional exponent. So I need to rewrite this as the cube root of x, because your base goes under your radical, the denominator is your root, your numerator is your exponent, but anything to the 1 we don't need. Okay, let's try this again on number 5. Now on number 5, I want to simplify inside of the parentheses before I do power to a power. This y, it's the only y. I can't simplify that. But with the x's, I have an x on the top and an x on the bottom. So I've got division. I do want to simplify the x's. And this is really just 1x. So to simplify this, because it's a division problem, I'm just going to take 1 minus 1/2. Well, I could get common denominators, but I don't need to. 1 minus 1/2 is 1/2. So I have x to the 1/2 and y to the 1/3, all raised to the 2/3. Okay, now I'm going to distribute that 2/3, and when I do power to a power, I'm going to multiply. So this is x to the 1/2 times 2/3, and y to the 3 times 2/3. Before you multiply, you always want to reduce. So that leaves me with y to the 1/3. Just kidding, I didn't mean to write that. Take that back. X to the 1/3 and y squared. Okay, anytime I have a fractional exponent, I've got to rewrite it as a radical to get to my final answer. So y squared, that's not a fraction. Don't need to rewrite it. X to the 1/3, I need to write that. And when I have to write my answer and it's going to be a radical and a non-radical, I got to do the non-radicals first. So I'm going to put the y squared first, and then this would be the cube root of x. All right, let's try this again on number 6. I'm going to simplify inside the parentheses first and then do power to a power. There's no other b's to work with, so I'm just going to work with the a's. So because this is division, I'm going to subtract my exponents. So I have 2 minus 1/3. Well, to be able to do this, I need common denominators. So this is 6/3 minus 1/3, so I get 5/3. 5/3. Now you'll notice a lot of these fractions, we're going to keep doing the same ones over and over again, so you should get pretty good at doing them. So this is going to give me a to the 5/3 times b to the 8th, and then all raised to the 3/4. So I'm going to distribute that exponent. When I do a power to a power, I'm going to multiply my exponents. So I have 5/3 times 3/4, and I have b to the 8th times 3/4. Before I multiply, I want to reduce. The 4 and the 8 don't cancel, but they do reduce. So on this, I get a to the 5/4 and b to the 6th. Anytime I have a fractional exponent, I need to rewrite it as a radical. And if I'm going to have radicals, I want the non-radicals first and then the radicals. So b to the 6th, not a fraction. Don't need to rewrite it. But this, I do need to rewrite. This is the 4th root of a to the 5th. Oh, but here's a bummer. This part over here, it simplifies. Let's see how it simplifies. This is going to be b to the 6th, okay? But if we think about this, this is 5 a's. Well, how many groups of 4 are in 5? There's one group, and then there's the one left over. All right, let's try number 7. Number 7, we don't have parentheses this time, but we've got a radical. When we've got the radical, we're going to simplify under the radical first, then do whatever root it is. So inside the radical, it says take 324 divided by 4. Okay, I can do that. That's 81. So I get the 4th root of 81. You can use your chart or you can use your calculator, but this comes out nice. The 4th root of 81 is just 3. That's it. Okay, let's look at number 8. I want to simplify anything I can under that radical first, then take the cube root. So x to the 6th is the only x. I can't simplify this. So this whole thing is going to be the cube root, but the y's, I have 1 on top and 10 on the bottom. Now I could subtract exponents and do all that stuff, but do what we did last chapter. 1 on top and 10 on the bottom, we cancel, and we're going to get 9 on the bottom. Okay, now we need to take the cube root of that. So the cube root of x to the 6th. Well, how many groups of 3 are in 6? And the answer is 2. How many groups of 3 are in 9? 3. So my answer is x squared over y cubed. Okay, let's try this again on number 9. Simplify anything that you can. Well, the y's aren't going to simplify any. The number won't simplify any, but I've got 4 x's on top and 1 on bottom, so I cancel and I get 3 on top. Now I'm going to take the cube root of everything. So how many groups of 3 are in 3? Well, there's 1. How many groups of 3 are in 2? None. That doesn't simplify, so I have to leave it as a radical. What is the cube root of 216? That's on your list, or you can put it in your calculator. You just get 6. Number 10. as we're simplifying this, I want to simplify anything I can before I take the cube root. With the numbers, 250 divided by 2 is 125. With the variables, x to the 6 won't simplify, but y, I've got 1 on top and 4 on the bottom, so I get 3 on the bottom when I cancel. So now when I simplify, the cube root of 125 on your list or use your calculator is 5. How many groups of 3 are in 6? There's 2. How many groups of 3 are in 3? 1. That's the final answer. All right. Oops, I don't have this part erased. Let me fix that. Okay, we have just 4 more problems to go. So on these, we've done some one with square roots. Excuse me, but now we're going to do them when there's something other than a square root. So here, as long as the root is all the same, it's not going to really change our work much. So I want to multiply these all together. So in my calculator, I'm going to take 4 times 16 times 2, and I get 128. So this is going to be the cube root of 128. Well, I can look at my chart or put it in my calculator. It's not on the chart. If I put it in my calculator, I'm going to get a decimal. So this is when I'm going to have to make a factor tree. So 128, I divide it by 2. I'm just moving this up here so I have a little more space. 8 and 8. 2 and 4, 2 and 2, 2 and 4, 2 and 2. Now it's cube root, so I need groups of 3. So here's a group of 3, here's a group of 3. So outside I have a 2 and a 2, cube root. Inside I have 1, 2 left over, so this is 4 cube root 2. All right, let's try this again on number 12. Because the roots are all the same, I can just multiply it. So 4 times 8 times 12 gives me 384. So this is going to be the 5th root of 384. Well, it's not on my chart, and if I put it in my calculator, it's a decimal, which means I'm going to have to make a factor tree. So I'm going to have 384 divided by 2, 2 and 192, 2 and 96, 2 and 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. We need 5. 1, 2, 3, 4, 5. So when I simplify that, the 2 is outside. Then inside, remember on the shelf I've got the 5. And then inside I have a 2 times 2, which is 4, times 3, which is 12. And that's my final answer. Now, 13 and 14 work the same way even though they're variables. So because the root is the same, I can multiply them. But when I multiply variables, I add the exponents. So I have 5x's and 6x's for 11x's, 3y's and 5y's for 8y's. Now it's the 4th root, so I'm looking for groups of 4. So in 11, oops, that's not what I wanted to write. In 11, there are 2 groups of 4, which gives me 8, and then there's 3 left over. In this 8, there are 2 groups of 4 and none left over, so that's my final answer. One last one. I need to multiply them together. Now the numbers I actually multiply, so this is the square root of 3 times 3, which is 9, but with the variables I add the exponents. 7 plus 3 is 10, so I have x to the 10th, and then y to the 9th. The square root of 9 is 3. How many groups of, remember there's invisible 2 here, so how many groups of 2 are in 10? Well, there's 5. How many groups of 2 are in 9? Well, there's 4, but there's 1 left over, so that's my final answer. These last problems we are going to save for our next lesson. Okay, we'll do that next class. Next class we'll do this and then a bunch of review and practice. Now on your homework, there's 2 things that I want to point out. Number 13, you need to add a 2. On number 14 or 15, you need to change that x to a y. And then 18 and 19, I want you to save for next time because we will do that next time when we learn about those. So we don't want to cross them out now, just save them for next time.